We're going to look at our second example with tree diagrams. This is a little bit different than picking marbles. This time what we're doing is we're looking at two events. One is Grant and Evan enjoy playing Legos, and then it tells us that there's an 80% chance that they're playing Legos. If they play Legos, there's a 10% chance that they will fight, and if they do not play Legos, there's a 30% chance they will fight. So with our tree diagram, what we have are two different things. We have event one, and event one is either Legos or they're not doing Legos. And event two is what happens when they're playing Legos. Either they're fighting or they're not fighting. Now, if they're not playing Legos, there's two possibilities. Either they're fighting or they're fighting. So this right here is going to be our tree diagram. When you're reading it, you have to know what event happens first and what event happens second. The reason that I could tell that the fighting is the second one, it says if they are playing Legos, there is a 10% chance that they'll fight. So the if means that it's the first statement. So we're going to be looking at Legos and fighting. Now it tells us that there's an 80% chance that they're playing Legos. That means 0.8 is Legos. And what we discussed before, our branches always add up to 1. That means this has to be 0.2. Now, if they're playing Legos, there's a 10% chance that they fight. So Legos and fighting would be 10%. Remember, the branches add up to 1, so that means not fighting would be 90%. Now, if they don't play Legos, there's a 30% chance that they will fight, 0.3. And if that's 0.3, this right here would be 0.7. Notice that it adds up to 1. So that right there is our tree diagram. Now it asks, what is the probability that they will fight? Now, fighting could either be one of those two. So that means that it could be Legos and fighting or not Legos and fighting. So we have to find both of them. So what we're going to do is we're going to go 0.8 times 0.1, and then we're going to add that to 0.2 times 0.3. So right there, when we add it up, what we have is 0.08 plus 0.06, which gives us a total of 0.14. And that would be the probability that they fight. Now for the next one, I noticed two A's. For the next one, what we have is the probability that they will fight if they are playing Legos. Notice the if. If they're playing Legos, we know they're playing Legos. Probability that they fight, 10%. And we could have guessed that in the problem because it kind of tells us in the problem. And for our last one, this is probably the most difficult because it says, what's the probability that they play Legos if they are fighting? Now, what makes this one difficult is that when we're looking at our tree diagram, what it's telling us is the last event. We know that they're fighting. That means that these two do not happen. It changes our universal set, which we talked about yesterday. So what we have to do is come up with the new universal set. Our two fighting models are 0.8 and 0.1, and we have 0.2 and 0.3. This is if they fight. Now, what's the probability that they play Legos if they fight? This is the fighting part, the given part. Now we need to do is look at those two models. Which of those two are they playing Legos? Well, in this part right here, they're actually playing Legos, the 0.8 and the 0.1. So we put that on top, 0.8 and 0.1. So when we simplify this, we have 0.08 over 0.14, or we have 8 over 14. 15, or we have 4 over 7, or if you like the decimal, 0.57.